Hi guys and welcome back to my channel. For today I prepared for you a new type of video, as you can see. Here I have a regular tetrahedron ABCD, and now let's draw the weight centers of the faces ABC, D1, which is the intersection of the medians, now on the face ACD, which is B1. Now I drew the center C1 from the face ABD, which is the back, and now let's draw the last center A1, which is the face BCD. Okay, so we have to find the measure angle of A1C1 and B1D1. Notice that A1C1 and B1D1 are in the space, so they are not intersecting in a point. By the way, this problem comes from my Olympiad. I had 24 problems, and this problem was the first one. I personally solved it, and I want to share it with you. So let's get started. You have to concentrate for this one. Look at the triangle BPQ. I drew the PQ line. Look, if C1 and A1 are the weight centers, we know that the ratio BC1 over C1P is 2. By the same, BA1 over A1Q is equal also with 2. If we have these ratios equal between them, by the Thales theorem, we have clearly that A1C1 is parallel with PQ. So we have to note this. Another helping construction is the next. Now look at the triangle AMQ, where MQ is the line built by me. Because B1, D1 are the weight centers of the faces, we have another ratio. AD1 over D1M is equal with 2. And also AB1 over B1Q is equal with 2. By the Thales theorem in the triangle AMQ, we clearly have that B1D1 is parallel with MQ. So we have to note this again one. And our problem becomes more easy, because we have to find, therefore, this angle from here. Because we have A1C1 parallel with PQ and B1D1 parallel with MQ. So the angle made by AC1 and B1D1 is congruent with the angle made by PQ and MQ. So we have the angle PQM from here. Now to find it, we don't know the side lines, because if we know that, so clearly we have that angle with a value. So I have to note that this triangle ACD is equilateral. So here we can write him, and Q is the middle of CD, and also P is the middle of AD. If we draw this one, we have that PQ is parallel with AC. More, here we have AC equals L, so PQ is L over 2. Also, we will make the triangle BCD, because he is also an equilateral triangle, with M the middle of BC and Q the middle of CD. If we draw this one, MQ is parallel with BD. Here is also L, because we have equal sides, and there's L over 2. So MQ is also L over 2. Okay, so far so good. And now I want to draw the MP line. So in this mode we have the triangle MPQ. And here I have an idea. If we prove that MQ squared plus PQ squared equals MP squared, we have clearly that this angle MQP is 90 degrees. So we have to show this. Obviously we have to find MP in terms of L, as we found here. So let's get started. By the way, we don't have to draw this one, so complicated lines. To find MP, the draw will be more simply. Next, we have to prove that MP is perpendicular to AD. And it's very simple why. If we draw the AM line, and DM from here will be equal with AM from here. Why? Because DM is the height from the triangle BCD with the side lines equal with L, and here also we have AM because M is the middle perpendicular to BC, where AB equals L. So that's because we have MD equals AM. So if P is the middle point of AD, we have clear that in an isosceles triangle we have that MP is perpendicular to AD, where P is the middle point. The hypotenuse DM, as we know, is L times the square root of 3 all over 2, because it's the height in the triangle BCD. Because P is the middle of AD, we have that PD is L over 2. So we have to find PM from here. This is very simple. From Pythagorean theorem, it follows that PM squared plus L over 2 squared is L squared over 4 is equal with 3L squared all over 4. So we have PM squared is equal with 3L squared over 4 minus L squared over 4. This is next with equal to L squared over 4. Simplify here and we have L squared over 2. So it follows that PM is equal with the root of L squared over 2, which is L times the root of 2 all over 2. So PM is L the root of 2 all over 2. Here we'll note that MP is equal with L times the root of 2 all over 2. Now back to our diagram and let's draw the triangle MPQ. Now if MQ squared plus PQ squared equals MP squared, we have that the angle MQP is 90 degrees. So we have to check. Now let's see. PQ squared is L squared over 4 plus MQ squared is also L squared over 4, which is equal with 2L squared over 4. We can simplify, so we have L squared over 2. And MP squared is equal with 2 times L squared all over 4. We simplify and is equal with L squared over 2. This is true. So finally we found this angle 90 degrees. So the angle MQP is equal with 90 degrees. More clearly, the angle made by these two lines is 90 degrees. So we solved the problem. Also guys, thank you for watching my video. I hope you will enjoy this video and understand it. And I want to say you